right, let's start over. 2.3. We're going to be looking at the second half of polynomial equations. And this half will explore a few different items that are related to polynomials that we didn't explore before. The first item that we're going to take a look at is something that we mentioned before, but we hadn't actually done it. It's called the Pythagorean theorem. The Pythagorean theorem is really just an application of the distance formula, because what it does is it finds the distance or length of a line segment between two vertices of a right triangle. If A and B are the legs of the right triangle, C is the hypotenuse, that is the side that's opposite 90 degrees, then A squared plus B squared equals C squared. And the description that it's referring to is that if I were to find this distance between these two, right here, it is equivalent to taking a look at a triangle and considering the sides of a right triangle specifically, and considering the side lengths of the triangle. So I have A on one side, B on the other side, and it doesn't matter where the A and the B are. It does matter that the C is opposite the 90 degrees. So all I'm really finding is a length here, a distance, and the Pythagorean theorem is an application of that distance formula. So taking a look, we're going to have a couple of examples. They're going to give us pieces of information, and it's not always the same piece of information we're looking for. On the first picture, are we looking for a leg or a hypotenuse? A hypotenuse. And the second picture, are we looking for a leg or hypotenuse?
Leg.
It's a leg. So you need to identify where those right angles are, and I don't have them drawn in such a way that they're marked. Your pictures, I think, inside of, I don't know, I think the pictures that you have inside of your work actually are marking them. If they're not, use your best guess as to which one it is. It should be pretty obvious, right, where the 90s are. Okay, so the homework does. Okay, I was thinking that the homework did. It's hard to get some of those images to show up when you're just using Microsoft Word. It's not the most user-friendly program for mathematics typing sometimes. It's okay, we'll be fine with it. All right, so we're going to look at the information that we're given, and we're going to use the Pythagorean theorem. So the Pythagorean theorem that we've had on the previous page looked like this. A squared plus B squared equals C squared. And if I use that, I just need to make sure, as an outset, that I get the pieces into the right place. So what's going to go where the A, the B, and the C are? Somebody tell me what you're going to write down as the equation.
9 squared plus 40 squared equals x or c.
Yeah, they use x on this particular one, so we'll call it x. Yeah, squared, yep. So I have 9 squared plus 40 squared equals x squared. And while it's super tempting to think that somehow you can combine the 9 and the 40 and then do the squaring afterwards, you cannot. Remember order of operations? Exponents happen before we add things together. So make sure you're keeping that in mind as you're working through these problems. I need to square the 9, I need to square the 40, and then add them together. So 9 squared, that's 81. What's 40 squared? Mm-hmm. And 1600 plus 81 would be 1681. And if it's a perfect square, this one happens to be, you can find it with your calculator. If not, we have to see if they'll factor. So you might as well try it. It's not a familiar to you number. What is the square root of 1681?
41.
It's 41. So that's very friendly on this one. That doesn't always happen. Oftentimes we're factoring pieces and pulling them out like we did on one of the questions you guys had during homework. So x is 41. So that one's a friendly one. On the second one, you identified that x, as it's presented in the problem, is a leg. That means it's the A or the B, and it doesn't matter which one you let it be. I'm just going to put it in for A. What would B equal if I do that?
6.
And C?
12.
12. Now, I need to move the 6 squared over, but I might as well just square everything that I have first. I'm going to have to do that eventually anyway. So 6 squared is?
36.
36. And 12 squared is? 144. We'll subtract our 36. What is 144 minus 36? What is it?
100.
108. Okay, so far so good? Wonderful. That's what x squared is. How do I find x? Square root. Now, typically speaking, when you square root, you have to put plus or minus. Why do you not have to do that here? It can't be negative. Why?
I guess you can't multiply the numbers.
Yes, so you're right in terms of the mathematical operations, it would work. But in terms of the context, what did you say, Simon?
Because it's a distance.
It's a distance. Our x here is representing a length or a distance, and you can't have negative length or negative distances. Okay? So we don't have to worry about pluses or minuses because we're working with distances here. 108 is not a perfect square. Did you try it? Yeah, it's not a perfect square. So we would attempt to see if it indeed would factor down any further. I don't know that it did. I don't have it written down that it did, so it probably doesn't. 108 certainly divides by 4. So I guess it will, actually. I take that back. I just didn't get it written down. Oh, I know why. Let me take a step back. Because the directions, I passed right by them and didn't look at them with you. The directions actually here tell us to round. So since we're going to round to the nearest hundreds, we don't have to simplify the radical the way we have been before. We will use our calculator to give us an approximation. And what is the approximation to the nearest hundredth? How many decimals is hundredth? 2. So we need 2 decimal places. What do you get?
10.39.
Mm-hmm. With 2 decimals of accuracy, it's 10.39. Okay, is that all right? All right, we kind of used a property in this one that we're about to define because it didn't actually come into play. X squared equals k. This is called the square root property. If x squared equals k, which it did equal something like that a moment ago, right? X squared equaled 108. And we want to find the solution, or all solutions to that, not just in reference to lengths. We can take square roots. But when we do that, we have to put a plus or a minus in the front. And the reason is because exactly what you were saying before with why that works out. So if I were to take the square root, for example, let's say it said x squared equals 4. And I were to take the square root. This x is equal to 2 and negative 2. Because 2 times 2 is 4. And negative 2 times negative 2 is 4. That's why the plus or the minus comes into play, is because when I square something, the negatives get eliminated. So when we're working with the square root property, that is, we're solving for x squared equals something, we need to remember to put on a square root. And that's actually the second part of this. The first part says that if the k value itself were negative, you'd have no way of getting a solution. In other words, so this is an example of the bottom part. Let me move it down here. In other words, if you had something like x squared equals negative 4, within the real numbers, there are not 2 numbers that are identical to one another that multiply together to give you negative 4. Right? 2 times 2 is positive 4. Negative 2 times negative 2 is positive 4. I can't take 2 numbers in our number system that we've been working with, multiply them together and get a negative number. That is the same number twice. It doesn't happen. So when that's the case, we have no real number solution. It's not really no solution. It's just no solution within the real numbers. And we will talk more about what happens in that situation, but it's in a further lesson, probably end of November. Okay? So as we're taking a look at these examples, we want to keep that in mind. All right, so number 3. We'll start with number 3. There are no directions, notice on these, that say round to the nearest hundredth, so we're back to actually simplifying radicals like we had been before. So do pay attention to the directions. Don't do what I do and ignore them. That's not good. It's never good. All right, so we have x squared equals 98. So what are we going to do? We're going to square root it. And when I do that, the first thing you might want to do is add that plus or minus on. And it's 98. And you don't want to stop there unless you've checked it and it's already in simplest form. You want to check that it's already in simplest form, and it's not. 98 divides by 2. 2 and what?
49.
49. 2 is prime. 49 is not. How will 49 break down?
7 by 7.
7 and 7. So that duplicating 7, so I have my plus or minus here.
Oh,
It's a 7, and then it's a square root 2. Do notice the placement of the plus or minus compared to the 7 in the radical, right? The plus or minus comes at the very beginning. The 7 that I pulled out would come next. The radical comes last.
That's the answer, right?
That's the answer. That's it. How about the second one?
X equals plus or minus 6, or I solved. You
There's-
radical, or you.
Okay, we're going to radical it.
I
Sure,
guess.
we're going to radical it. We're going to take the square root. It's not plus or minus 6, though. Look carefully.
6, positive 6 on, negative 6 on.
Well, it is, but we're not working in that number system. So what does that mean?
Well,
It just means not just the only way to take out the negative.
You're right, it is. So domain error in your calculator.
domain error.
Yeah. Okay, what did we just say over here on the first step?
Radical. Wait.
What does step 1 here say?
Oh,
You can't do it in the real numbers. That's what it says. All right. So you're exactly right, Chase. We are definitely going to get to I's. I think it's in I don't know. I feel like I should tell you now that you're actually
man, I
talking
felt
about
so
them.
confident about that.
I'm so sorry. How about 2.9, complex numbers, 2.9. When we get to 2.9, we're going to do exactly what you just said, but it's a while. It's a while. What we're working in right now is the real number system.
Yeah.
Okay, in the real number system, there are not two identical numbers that multiply to negative 36. I can't get the negative. So this actually is no real solutions.
Dang.
Pay attention to those signs. No real solutions. Okay, number 5 is going to look a little different. At first glance, this does not look like one of the problems I just did. It doesn't say x squared equals something. But there is a square, right? Something is being squared. So we can actually use the square root principle here in a much easier fashion than if we were to sort of FOIL this all out and then refactor. Foiling and refactoring would take us a bit of time. It's not impossible, but it would take a while. The square root principle is much cleaner. So what we're going to do is we're going to move the 32 to the other side. That leaves me with the w minus 8 squared on the left and 32 on the right. Everyone good so far? Okay. Now I can't just take w minus 8 equals 32 or something like that. That's not the way it works. That only works when it's set equal to 0. But what I can do is what I did in the last two problems. I've got something squared on the left, and I can eliminate the square by taking a square root. So if I take the square root on the left, then the square and the square root are inverse operations, and they go away. So on the left-hand side, I'm left with w minus 8. But I put a square root onto something, which means what do I have to have when I take square roots?
Oh, the plus minus thing?
Plus or minus. All right, when I put a square root onto something, it better have plus or minus. I still need to simplify the 32 part of it, but I need the plus or minus. Okay, it's very sort of just easy to overlook the plus or minus. Don't forget it. 32 needs to be factored. How can it factor?
4 and 2, right? Or sorry,
8 and 4.
Yeah, you're right, it is. 4 and 8 would work, right?
Yeah.
4 is 2 and 2. 8 is 2, 2, and 2. So there are these two 2's and these two 2's, and this one gets left underneath the radical. So I still have the plus or minus. I'm pulling out a 2 from here and here. 2 times 2 is 4. This 2 that's underlined is left still underneath the radical. And w minus 8 is still on the left-hand side.
Is that it?
We're almost done. The goal is to solve for w.
Oh, yeah.
What's the last step? Yeah, I need to add the 8. Okay, 8 as a standalone, right, it's just its own little number, cannot be combined with the 4 square root of 2. 4 square root of 2 has two pieces that are already being multiplied, the 4 and the square root of 2. 8 doesn't have a square root of 2 multiplied by it, right? So I can't add this 4 and this 8 together in any compact way. Like, I can't simplify it. The best that I can do is to simply write it at the beginning, right? So I put the 8 at the beginning of this, and then I have the 4 square root of 2 that comes after it. You cannot simplify that in any way, shape, or form and keep the number exact. Now, the reality is this is 2 answers. I'm not going to ask you to write it this way. It kind of indicates maybe that it wants you to in your notes or in your like homework parts. But it's 8 plus 4 square root of 2, and it's 8 minus 4 square root of 2. That's what the plus or minus means, right? I have 8 plus this value, and I have 8 minus this value. These are the 2 solutions to this problem. But it's perfectly fine, good gracious. It's perfectly fine if you leave it written in that compact plus or minus form, but you can't do anything else to simplify it down. Okay? We're going to do a very similar problem for number 6. You ready? W plus 9 squared minus 25 equals 0. What do we do first?
Add 25 to both sides.
Yes, we do. We add 25 to both sides. So on the left, I have W plus 9 squared. What do I have on the right? 25. What's next?
Square root.
Yeah, you're right, Simon. Yeah, so we're going to square root. And when we square root, we have to remember
Cancels out the exponent.
plus or minus on the right, and it cancels out the exponent on the left. Yes. So these cancel on the left, leaving me with W plus 9. And on the right, I have the plus or minus, but we can do square root of 25, right?
It's 5.
It's 5. Now this one's different than the last one. I don't have any radical piece left. So when I move my last bit of information, that is my positive 9, I will be able to combine it with the 5 and the negative 5. Right? So I'm going to subtract my 9. And I will have 2 answers. One answer is the positive 5 minus 9. The other answer is the negative 5 minus 9, right? Plus or minus 5. So you can't leave this written as negative 9 plus or minus 5 because it can be simplified, whereas the last one could not. So what is 5 minus 9? Negative 4. And what is negative 5 minus 9? Yeah, negative 14. So these two actually have the ability to clean up, so we will separate out the answers. Yep,
You're
Nolan?
supposed to write out the whole 5 minus 9, not
No, you wouldn't have to. I just want to show you where it's coming from because it looks different than the last one. Yeah. Yeah, so could you jump straight from the W plus 9 equals plus or minus 5, subtracting your 9 to get to these? You could do that. Yeah, that's fine. Okay, all good? Okay, we're close to the end. We have one more formula and one example. Excuse me, one example. And this is called the quadratic formula. You've seen it before. I know you have. The quadratic formula is yet another way to solve quadratic equations. Okay, so in the last section, one of the ways to solve quadratic equations that we found was factoring. We did some simplified factoring. We talked about the AC method, which seemed like over and above what we needed, and it was. We'll talk more about it later. And this section, we've talked about the square root principle. That's a way of solving. This is a third way of solving quadratic equation. The quadratic formula, excuse me. So if a squared plus b squared plus c equals 0, a, b, and c are real numbers, which they will be given to you that way, and the a is not 0. What would happen if the a were 0? Oh, there's a typo. I think I was supposed to fix that when I did this before. It's ax squared. So sorry if that's still, is it fixed in your notes? No? Is it still wrong?
It just says a squared.
Yep, it should say ax squared. I need to get that fixed on my screen too. Maybe I'll remember when I get back to my office. It's a definitely maybe. We're going to try. Should say ax squared. Okay. What would happen if a is 0? you get a line, right? If the a were 0 here, written correctly, ax squared, but if the a were 0, it would go away, and I would just have bx plus c equals 0. Well, bx plus c equals 0 is a line. So if we're dealing with a line, the quadratic formula doesn't make any sense to use. That's why the condition is that a can't be 0. Okay? So have you seen this formula before? Yeah? Have you heard this song?
No.
Ooh, you want to hear a song? Do you know the tune? Oh my goodness, James is going to just have a, wow, he's just going to lose it for me today. Okay, so this will be the only time you're going to hear me sing. I don't really like to sing in public. My husband's a worship minister. He can take care of that. All right, so it goes to the tune of Pop Goes the Weasel. Do you know Pop Goes the Weasel? It goes something like this. X equals negative b plus or minus radical b squared minus 4ac all over 2a. So there you go. Thank you so much. Appreciate it, Nolan. Yeah. Okay, so I don't care how you memorize it, but you need to memorize it. It's a formula that comes up quite frequently, and all of you intend, at least you intended when you started this class to go into college algebra, you're going to see it again. So if you don't memorize it now, you're just going to memorize it next semester anyway, so just memorize it. And the nice thing about the quadratic formula is that it will allow you to solve any quadratic equation, period. Not all quadratic equations factor, because you don't. And not all quadratic equations can use the square root principle that we used on the last couple problems. But all equations can be solved with the quadratic formula. Okay, all quadratic equations can. All right, so here's our example. I'm going to write the quadratic formula over here. Okay, so that's our quadratic formula. What we need to make sure we do is we correctly identify a, b, and c. That's valuable information. So in this formula, or I'm sorry, equation that we're given, what's a?
9.
9. What's b?
4.
And what's c? 1. And these happen to all be positive. They certainly wouldn't have to be positive. Oh, in fact, let me pause just a second. I didn't write this part up at the beginning, so I didn't notice it. The form of our equation isn't quite where we need it to be to identify all the pieces. I need to do something before that. Notice the c in the equation at the top is on the left-hand side, and it's set equal to 0. Do you see that? But ours doesn't look like that. How do we get our equation to be set equal to 0?
Subtract 1 to both sides.
Yeah, I need to subtract 1 from both sides. So the 9x squared is good. The 4x is fine. And then it would have minus 1. So c does, in fact, equal negative 1, not positive 1, once we put it on the right side, the left side, actually, of the equation. Okay, all good? Let's put it in. X equals negative b. Well, what's b?
B is 4.
Right, so negative b would be negative 4, plus or minus the square root of b squared. Well, b squared is 4, so I have 4 squared. Minus 4 times a. What's a? 9. Times c?
Negative 1.
Negative 1. All over 2 times what? 9, because 9's a. Just getting it in there is worth something, right? So make sure you get all the pieces in the right place. Be careful on that part. One of the other things that will happen often is that students will forget that the division sign goes under everything, including the number negative 4, in this case, the front. It doesn't just start under the radical. It should go under the entire expression on top. So let's actually do some simplification inside the radical. I'm going to leave the negative 4 and the plus or minus where they are. What is 4 squared? 16. So that's the first piece that's underneath my radical. 4 squared, 16. Now I have negative 4 times 9 times negative 1. 36. Positive or negative? Ooh, I hear both answers. Is it positive or is it negative? Gabe, what do you think?
Because negative 4 times 9.
Yeah, it's ultimately going to be positive. There are 2 negatives here. Yeah, and some of you are seeing it right now. There's a negative here and a negative here. So I do have two negatives that are playing into this. So I do have a positive 36. Good job. And then we're having this all over what? What's my denominator? 18. What is 16 plus 36? 52. Okay. This 18, we need to be careful. This 18 is not just under 4, and it's not just under the square root of 52. It's under both of them. So we can't just reduce like the 4 and the 18, because that would have forgotten the fact that it's underneath the 52, okay, the square root of 52. However, what we can do is we can simplify the square root of 52. So let's take a moment and see if we have the ability to simplify that. So how will 52 factor? By 2 and 26, good. And then 26 can break down further. 2 and 13. So can we simplify square root of 52? Yes. There's a couple of 2's there, right? Yes, we can. There's a couple of 2's. So I can rewrite this piece. We'll move it up here as the negative 4 plus or minus 2 square root 13. At this point, the negative 4, the 2 in front of the square root 13, and the 18 do all have a 2 in common. And I can divide them by 2. So why can I do it here, but not over here? Well, the reason I can't simplify the 18 with the 52 over here is the 52 is underneath the radical, right? Okay. The reason I can do it here is not because I'm ignoring the square root 13, but because the square root 13 is actually being multiplied by the 2. So I can reduce the 2 with the 18 and preserve the square root 13 without any problem. It's not a big deal because it's all multiplication and division. It's all multiplication and division. So I have the ability to do that. So I'll take a 2 out of each one of these pieces. So negative 4 divided by 2 would be negative 2. Positive or negative 2 would end up being a 1. So feel free to write the 1 if you'd like, or leave it off. And the 18 divided by the 2 would be a 9. You don't always have the ability to simplify these pieces. The square root 52 could have very easily been the way it is and we're done, right? At this point, if I factored something from the square root of 52, it could be very much that like the 4 at the beginning, the 18, and the number in front of the square root 13 don't have anything in common. They don't factor. But you don't know until you check.